Welcome everyone to the 7th in the series of Building Science Deconstructed live webinars. We are proud and pleased this week to feature Gord Cooke from CI Live, Construction Instruction Live, where he will be taking us through a solid structure starts with a solid foundation. So he'll be talking about good basement practice. If my slides will move forward for me. Durkin has been manufacturing moisture protection products for 125 years. We are still family owned and still owned by the same family. This is a lovely shot of our head office in Western Germany, a little town called Haddeke. Today's presenter, Gord, is a partner with Construction Instruction. He's a professional engineer with over 25 years experience in the low and high-rise residential building industry. Some of his career highlights include a regular contributor to many industry publications, and he writes a monthly column on HVAC systems for Mechanical Business magazine. He works with Enerquality Corporation and the Ontario Home Builders Association, where he is a Hall of Fame inductee from 2007. He's a member of over 12 industry associations across North America. He's chairman of the Canadian Standards Association F280 Residential Heat Loss Heat Gain Standard, which now recognizes proper sizing of mechanical systems in high performance homes. We've had Gord speak with us before, and we hope to have him speak with us again in the future. He is very informative, entertaining, and please ask questions along the way. You will find a Q&A box on the screen, so please type all questions in there. All attendees will receive an email that will have a link to the recording of this webinar, so you can view it again in the future at your leisure. Without further ado, here is Mr. Gord Cooke.
Thanks very much, Peter. Thanks for having me again. Last time I was here under the EBA banner, Energy Environmental Building Alliance, great organization, and Construction Instruction, our firm in Denver, is their education partner, so I was pleased to provide something there. And then this particular session comes out of a bunch of work we've done in Canada. That is, I am a Canadian. I live and work out of Toronto, Canada, and we've been doing a lot of work with high-performance builders across Canada, I would say. Well, for sure across Canada, if not United States as well. And my partner, Andy Oetting in Building Knowledge Canada, suggested that there was some good experiences we've had with basements. Today's perhaps a good day to talk about this. You may hear bangs of thunder. I do live in a net zero house. I'm coming to you from my net zero house that we built about 5 years ago, and it is incredibly quiet, but not necessarily enough to overcome Mother Nature and the loudest of bangs. But tremendous rainstorm earlier. I happen to know my neighbor's house, which was built in 1886, right across from me here, is undoubtedly got water in his crawl space today. And my brother called last night, City of Toronto, and said his 1910 basement had flooded. So perhaps a bit appropriate to start with this conversation, which is we've learned a little bit in the last 100 years. If we're going to, not if, when we're going to build high performance buildings, we really need to start with a solid structure and therefore a solid foundation. And so that's the premise of this particular talk and where we're going with respect to basements. If you don't mind, I'll take a quick second just to remind folks of who Construction Instruction is. That's Mark Liberté, Justin Wilson, and myself. Justin's in Denver. Our CI facility is in Denver, and Durkin, we're very proud to have as a sponsor, a partner with us in that facility. Mark's from Phoenix, I'm from Toronto, and together we've been road warriors, of course, over the last number of years, doing training education across the country. Now we're doing it remotely, and so pleased to see so many online. Hopefully everybody's staying safe and finding a way to help loved ones stay safe over the next 18 months or so, I think is probably where we're looking. So thanks for that. Most of you may know that Durkin and other manufacturers are partners with our app, free construction app. Go to constructioninstruction.com. You'll find the app on any one of the major platforms and find good building science. Some of the animations you see on this presentation will show up on the app. We set out a goal at the start of 2020, thinking 10 years down the road, that our job as a company was to help those we interact with, both manufacturers, builders, trade contractors, to get to zero energy by 2030 and zero defects by 2030. And we feel that building science can be a tremendous help with that. This series is an example of that. That simultaneously, if we solve basement moisture issues, we can also solve the energy issues associated with basement heat loss. And so that's our goal, is to work with folks who are committed to the understanding of you should be able to get to zero energy and zero defects by 2030 in residential construction. And we have created this, Peter alluded to it, our CI Live Center, Experience Center. As things move along and as we clear up, we hope to see you come to our Experience Center, where we have lots of great demonstrations, practical demonstrations of very much the kind of topics that we're thinking of today. And again, I'd ask you to check out our website. In terms
Just let me add there, Gord, that I've been there several times and it's a great experience. I encourage anyone to go.
Thank you, Peter. We've really enjoyed having you there. Justin was just telling me yesterday he's just put in a new slab demonstration showing moisture levels. It's actually poured a concrete, small concrete slab where he can inject or dry moisture, and he was very excited by the results, and folks need to see that. So that'd be great. So I thought I'd start with, and I have the wrong slide up, my apologies. The wrong slide, it's okay. But in terms of today's agenda, we're going to start with where we started with basements as living space, some of the building science connections, the changes to finished basements, the challenges to finished basements, and getting to what we'll call that perfect space, the dry, warm, healthy, efficient, profitable space, and maybe some of the housing initiatives that can help you with that. So we'll just work through these items in the next 40 minutes or so. And I always like to remind folks, and I did it on the EBA call, what were we really starting with? And the goal, of course, is to get us to solid, stable ground. That's where we'd like to get to. And that means we need to know a bit about the soil capacities, a bit about the soil types, and lots of research on that over the years. The one that I'm going to key in on for, well, hopefully obvious reasons is moisture. Moisture both in liquid form and in solid form. To understand that moisture really is a controllable risk, something that we can manage, and very valuable to thinking about the long-term success of livable basements. So I'm not a structural guy per se, but I certainly can help you with the structural problems associated with moisture that we want to think about. And so that all starts with this conversation of why did we dig the hole in the first place? And frankly, it was frost protection. Actually, more definitively, it's water that's turning into frost. Understanding that water, when it freezes, it expands by exactly 9%. Interestingly enough, so you have these soils, water in soils, the water expands, that puts tremendous pressure on any immovable objects, or Mother Nature doesn't see them as immovable, but these objects called foundation walls, foundation slabs. And interesting enough, although it expands 9%, it can actually move soils more than that 9% through an impact called lensing, the way frost is built in that ground. And I'll show you a slide on that just in a second. So it can lift soils easily a foot or more. Some of you may actually be in soil conditions, expansive soil conditions, where you get a similar effect with moisture, not when moisture freezes, but when it comes into contact with specific clays that will absorb that moisture and also expand in that order of 6 to 8 inches. People have seen that in Denver and other locations. So this idea that moisture in liquid form is our enemy, and then moisture in solid form becomes an extra 9% that we have to worry about, and the impact that has. And so that's why we dug basements in the first place. And we really have two strategies to control that impact. One, control the water, or two, control the temperature of the footings so they don't freeze. I mean, that's the history of digging the hole. And so typically we find ourselves doing both of those. We think about surface drainage to minimize water on the right-hand side, that impermeable cap to flow water away, then promoting free drainage below grade. And of course, great partner to working on the call is the expert in that. And then using the earth to insulate the footings. And I don't know if that's too fine a point, and maybe you've heard this before, but really when you think about the frost depth, if I went back one slide, you think about the frost depth, that's really telling you how many inches of dirt you need in order to insulate the footings from the frost. In other words, dirt has an insulation value. Its value changes a little bit depending on the soil, depending on the compaction. The highway ministries are always, they in fact are the ones who publish these kinds of drawings because they're very interested in frost heaving underneath highways, and they worry a lot about soil compactions and so on. But typically, if I could put a number on it, it's about R2 per foot. That is, if you have 5 feet of dirt, frost line is 5 feet, you're basically protecting your footings with R10 of insulation. Hopefully you find that interesting if you haven't heard that before. And then you also need to think a little bit about, because just managing the water and the thermal performance at the footing level doesn't necessarily cut it. You have to worry a little bit about adhesion, depending on the soil's adhesion, or sorry, freezing, where the ice, so that's on the above frost line portion, that actually can adhere to concrete and various other materials and push it up, pull it up, and so on. So that's called ad freezing. And there's just a little example of that. And so you have these two combinations of ad freezing and ice lenses. The lenses actually exacerbate, or, well, much like a lens when you think about focal points and focusing light. In this case, the ice lenses actually focus these forces, these vertical forces, and can actually move that soil, as I say, more than a foot. So we have to think about water in liquid form. We also need to think about slip planes and so on to keep that frost away from that foundation wall so that it's not pushing her up on that foundation. So water in solid form is a big problem for us in northern climates. And I'm assuming everybody on the call is northern climates. You've tied into basements. If you're from the south and still doing basements, fine. You still need to worry about water in liquid form. But for the moment, I'm thinking about water in solid form or ice and the damage it can do. That's historically why we went below grade. That's why we dug the hole. Of course, once we've dug the hole, we found other uses for it. I mentioned my brother phoning me last night. This is his house, built in 1910 in Toronto. Beautiful picture there. Last night, not such a great picture, basement flooded. So even Jim, even though his basement was never designed as living space, he did use it, they did use it for mechanical systems. There you see on the right. And if you look closely on the right, you'll see the brick wall in this case. The part of the foundation is out of a brick. Some of it's actually an old rubble stone foundation. There's actually 3 different iterations in this house. One is a concrete block, but you'll notice the water, that efflorescence, those salts on the brick on the right-hand side, that's an indication that water's coming through from outside into the basement. And the good news is it hasn't done a lot of damage. That piece of the foundation is roughly 80 years old, and it's still standing up. Why? Because the moisture was allowed to dry to the inside. So Jim's using that for mechanical systems. Obviously, there on the left, some storage. Some would say safe haven during storms in the Midwest. We often think about tornado and safety down in those spaces, so that's great. But you've noticed my brother Jim here on the left is trying to eke out some occupant activities in the basement. So we've counseled him. He's learned to put everything in plastic tubs because it's going to get wet. But he is using it for, I would say, fairly low risk occupancy elements in that house. So when you think about how we have struggled, or at least challenged ourselves to use basements, could we do a better job? And that's really what this session is about. And of course, we have these new expectations, right? Here's what everybody imagines this living space to be: the incredible finishes, the ambiance, the lighting, drywall, all the materials that you might want to put into a basement now. And of course, we want it to be warm and dry and bright and healthy, and frankly, adaptable, probably even more adaptable than above grade, because every customer has something different they want to do. Some want to put renters down there, some want to put pool tables, some want to put theater rooms. So we have to build or think about those basements even if we're not finishing them, we have to imagine ourselves, imagine our clients and what they're going to do with that basement over the years. And probably a wider range of uses, as I say, than most of the rooms upstairs that we have to think about. So those new expectations are pretty powerful. And so when you think about your risks as builders, as architects, as contractors, the risks, I'm going to say to you, it's all about water because we're below grade. But then there's this comfort element. We are, certainly in northern climates, frankly, in all climates, we're below grade, which means we are constantly damp and cool. The soils are cool, the soils are damp. So we have to think about comfort in those spaces. You think about, again, my brother's house, they're not spending extended periods of time in that basement doing very limited activities. When you think about this basement, boy, people could be there for extended periods of time, and therefore their expectations of comfort go up. And as I said to you, we have to think about what would be suitable finishing materials. You think about above grade, the ubiquitous material, very cost-effective material, you see it there on the top of that picture, is drywall. Well, is drywall a suitable material? Drywall being so susceptible to mold and moisture damage, moisture and mold damage, I should put it that way. Should we be thinking about other materials in that basement? And then you're going to say to me, and I recall we had David Bricks on our call just a little while ago, and he was chatting about sequencing. Could we do this in the right sequencing of these constructions so that it doesn't interrupt your flow and your profitability and margin and so on of that. And then, of course, we need to think about the long-term warranty. Basements tend to be, finished basements tend to be one of the highest warranty items. And here's one of the biggest risks. What are the risks if they finish the basement instead of you? That is, I know a lot of builders would say, I'll let the customer do it. But frankly, in today's world, you're still on the hook. I think you would agree with me. They decide to put down a flooring material that wasn't particularly compatible. They put up drywall that wasn't particularly compatible. They put on a foam insulation down the bottom left. That happens to be a good choice on that wall, but what if they chose the wrong insulation? Are you still at risk? And I would suggest to you that the current experience I've had in court cases and so on is you're still on the hook if in fact they can lead back to you didn't manage moisture correctly. So risks and opportunities. And if I took you back to the building science connections, and you guys would recognize the terms air, heat, and moisture flow, in this conversation for this day, we need to think primarily about moisture. Yes, we're going to talk heat flow, but the single biggest issue, I already mentioned it when we looked at the drawing on the right, the number of moisture sources. We are just such great risk 24 hours a day. Above grade, there's many, many days. In fact, we haven't had a drop of rain until today for the last 3 weeks in my marketplace. So the above grade walls, we're laughing. The below grade walls, actually, we're still subject to moisture issues because that moisture in the ground is there all the time. So many moisture sources that we have to worry about in that scenario. And so the code has addressed that. The code has said, yep, we have to think about moisture migration. And the code basically looks at two items. One, damp proofing. Damp proofing is primarily to stop capillary flow through porous items. We've chosen to use concrete in almost all cases. We use concrete or concrete derivatives in basement walls, foundation walls. Concrete, of course, wicks water, and we'd like to manage that water. The concrete itself doesn't really mind the water, the moisture, but we don't want it drying to the inside, so we're required to put up damp proofing, and that's U.S. code. I'm sure there's some Canadians on the call. Very, very similar wording, right, that we have this requirement for damp proofing. I'm going to be very, very blunt. This is the minimum. The minimum that you need to do is stop the capillary flow coming through that basement wall. That's the important thing to keep in mind. In the building code, the IRC says, well, if you're in high water tables, severe soil water conditions, you need to go further than that. You need to waterproof the wall, a second terminology, not just damp proofing, but some mechanism for stopping liquid water flow through cracks and so on. Interesting, isn't it, that that's not a requirement in all locations, just a requirement where somebody's determined high water table or other severe soil conditions. In Canada, we've done something slightly different. We recognized actually back in 2008 that damp proofing wasn't enough. Why? Because in that year, it's actually a little bit before that, we were requiring full height basement insulation. And we realized, the code officials, the building industry, realized that simple damp proofing wasn't enough really to keep the insulation systems dry. So they went a little bit further and suggested that in addition to damp proofing, waterproofing options, that foundation wall drainage systems were also a preferable, or at least a preferred methodology. And virtually all builders in my market, heavy clay soils, that's Ontario, Canada, about 50,000 houses a year, all of them use, well, 90% of them use a drainage system such as Delta MS. You guys are be on this call will be familiar with that. And Delta MS is code approved from a drainage perspective. So I just want to make the point as I leave this slide, the minimum is damp proofing. And I'm going to say to you, it's no longer good enough because you're insulating and finishing basements. And if you're not finishing, your client is finishing basements, and it puts you at risk. If all you've done is stop capillary flow, you have not gone to the extent that you really need to get to. And so I'm saying to you, code's not enough because there are so many moisture sources. If I cued you in on this slide, when you think about damp proofing, which of those would damp proofing actually, simple damp proofing, actually stop? Well, frankly, the summer inward vapor diffusion about a third of the way down. Okay, I guess we could stop that. The capillary water flow through that wall, we could stop, but it wouldn't necessarily bridge cracks or unsealed rod holes, as you see there. It certainly wouldn't stop water wicking up through the footings because we don't put a damp proofing there. And it wouldn't stop liquid flow getting through cracks from rain infiltration and so on. So capillary flow is damp proofing is a minimum requirement. And then we need to think about doing a better job. And that's where we think we know drainage is a more appropriate answer when we look at how we're upping the ante with respect to how basements are going to be finished. And I'm going to use this statement, you can't insulate until you've addressed the water. This was a phrase we often use. We were doing indoor air quality audits for a housing authority here in Canada, and we had to tell people in their basements that they should not use their basements as living space. This is an existing basement. They should not use their basement as living space. They should not insulate their basement wall. I've told my brother Jim, do not insulate those basement walls. They are not suitable because you haven't managed the moisture in those walls. So very powerful. So if we start with what am I talking about when I say managing moisture, here's a little shot of that. Notice that blue element down at the base. That's a product called footing barrier. It is, in fact, a capillary break on top of the footing, stopping the water that was wicking, you saw in the last slide, wicking up into the wall. And then on the outside of that wall, we have a little cold joint there to stop that cold joint potential leak there. And then we're talking about a drainage membrane on the outside, which simultaneously gives you your capillary break, gives you your damp proofing, or the qualification of the equivalency of damp proofing, but adds this really important element of drainage, taking away liquid water. And interestingly enough, we know concrete cracks. That was one of the major studies that was done in Canada years and years ago. The study came back saying concrete cracks. And we're like, yeah, of course it cracks. And there was two ways to figure out, to solve that. One was to try to stop the cracking or fix the cracks. The other was to do the drainage. And we've realized that holes in the concrete aren't a problem if water's easier for water to drain down than it is into the wall. So drainage, this comprehensive drainage system that you're seeing here, directing that water away to the footing. Peter.
Well, first of all, thank you, Gord. That sounds very Canadian to do a study to find out that concrete cracks.
Attaboy.
We probably have a study to find out that water's wet as well.
Yes, exactly.
So since you're on the topic of foundation walls, maybe you could comment on the using this when you're not using a poured concrete wall. Sometimes there's ICF and sometimes there's block.
Thank you for that. Block is even more susceptible, even more important. There's inherent holes in in the concrete block, just the mortar joints and so on. So absolutely vital that we get a drainage layer on there. The ICF is an interesting one, because some will say, well, ICF, the EPS foam, that's watertight. Actually, no, it isn't. The concrete still cracks. The EPS joints aren't inside the, maybe crack less, but it still cracks inside the ICF forms. So ICF forms, wonderful product. I haven't shown any slides of that, and I'll say right up front, ICF, by all means, go to ICF, but it still needs to be water managed. And so you would still put a drainage layer. And rather than fiddling around with a damp proofing layer that you don't know if it's compatible or not, or a peel and stick on an EPS foam isn't compatible, I actually prefer drainage layers. Even more important to apply drainage layers onto ICF. And then you've got yourself a really well insulated, water managed foundation. So thanks for that question, interjection, Peter. That's very helpful. So this idea of this really nice, when you think about solving the water issues, all of the water sources, now you have protection against all of the water sources. You stop the capillary flow coming up from the footings. You stop the capillary flow. In this case, you're seeing underneath the slab as well, stopping that capillary flow, vapor flow. You've got drainage on the outside, which means any liquid water is drained down to the footing drains, and you've stopped the capillary flow through the walls. So now that you've done that, now we can get ourselves with these very simple, effective investments. This happens to be the house that I'm sitting in, the footing barrier being applied to that footing. And I found it pretty interesting. The contractor who'd never used it before to the front, he actually wanted to feel it. What's going to happen with this product? If you haven't tried this product, seen this product, I think it's a pretty brilliant product. Very simple to apply. We've shown it in other sessions, so I won't go too far into it. But my point here is, there you can see on the block wall, Peter, on the right-hand side, the idea with these very simple investments, very early in the construction phase, now you get yourself covered for the rest of the build. We use that tagline, solid foundation for a solid structure, a solid start. And this gives you that confidence that now I can go almost with impunity and go ahead and do whatever I need to do, want to do in that basement, and provide really nice livable spaces. So that's really the key. And then as we move so we've solved the moisture. Solve is perhaps too strong a word. There are still going to be soil conditions. There are still going to be situations where you have to go to greater lengths. But for the most part, for most of the builds, those two simple investments really help you from a moisture management perspective. And now we can think about optimizing insulation. And you might fall into the trap. I know people on this call are educated enough that they would understand that this isn't a case of people always think that heat rises. Well, it doesn't rise. Heat moves from hot to cold. And there is the heat loss through a foundation. These figures, by the way, come out of that study I mentioned, a big study that was done back in 2005 and a precursor to that, 97. But this idea that the heat flow from the left through the house, through the slab, down through the soils, out to the cold spot, which is Mother Nature. So we just need to get our understanding. And interestingly enough, when you think about that heat flow, it gives you opportunities to solve it in different ways. That is, we don't really care where the insulation goes. It literally could go under the slab. It could go on the interior of the foundation wall, or the frost wall in this case. It could go on the exterior of the foundation wall, or it could even grow on the horizontal below grade, just under the grade on the right-hand side. So we just need to impede or stop that heat flow. And you remember, dirt itself is an insulator, R2 per foot. Of course, we have much better insulators than that. We have insulation at R5, R7 per inch. So let's go ahead and be more effective than Mother Nature at stopping heat flow from our basements. But a fairly simple little drawing. And if you're wondering, is it mean a lot? The answer is yes. If you notice in a HERS index, this is US, a HERS rating, HERS index house, a typical house in a cold climate. In a cold climate, I'm talking climate zones 4 and above, that basements account for 25% of the total heat loss of a house. And even typically when you drive down to a lower HERS rating of, say, HERS 50, typically builders don't do the basements. They do everything else first. They get the air tightness done, they do better walls, they do better windows, but they don't necessarily take the right stab at basements. And I'm going to make a case that basements are the most cost-effective place to insulate as long as you've done the water management first. They are the lowest risk, lowest cost way to bring down the HERS score. It's not the only thing you would do, but somewhere along the line, and I'll actually show you how much insulation to add to make this work for you. So there you have it. And I mentioned to you some helpful studies. This was the 2005 study, the one on the right, Ted Kessick, a great researcher at University of Toronto at that time, now with Ryerson. But Minnesota and Ontario, Canada both did simultaneous studies, Pat Holman at University of Minnesota. And what I'm going to show you here really comes from those folks as to what's cost effective, what systems might you want to use. And it turns out this is a pretty busy slide. I'll take just a second to show you. Don't worry about it too much because I'm going to show you other pictures on this. But you have three strategies. You can insulate from the exterior on the left-hand side. You can insulate from the interior on the right-hand side, or you can do a hybrid of inside and outside. And that hybrid is kind of an interesting one. I'll key in on that in just a little bit. Minnesota very clearly went towards exterior insulation, and we can learn from that. It's a great opportunity to think about where is the best place to put the insulation. If you're worried about sequencing, worried about is this going to impact the further construction of my house, if it's all done on the outside, boy, you do that before you backfill and you're good to go. You've got things done. So it can be really helpful. This is actually a drawing from the Minnesota copyright, copyrighted by the Builders Association of Minnesota, showing how you do exterior insulation on the outside. R10, R15, depending on what section of the code you're working under. The issue always becomes, so how do I provide above grade protection? And they have various strategies to do that. I'll highlight that in just a second. This is a pretty typical manufacturer's response to that. The blue foam, in this case, XPS foam, showing the above grade, and they're showing a corrugated metal protection sheet above grade. They have parge coatings that they sometimes use on foam. It's almost always foam. It doesn't have to be foam. There are mineral products as well that can be used. I prefer the foam products on the outside with a specific drainage layer. What's really nice here, it keeps the concrete warmer from a comfort perspective, a moisture perspective. That's always nice. It helps reduce water entry, of course, because of the water management layers that we have. Some would say it's a challenge to finish above. We do need to think about that thermal bridge down at the bottom through the footing. What are we going to do with that? There's still a thermal bridge there, but that ends up being a relatively small portion of the heat loss. Even in a net zero building, you might not need to attack that. Now, if you're in Alaska or something, it might be different, but that tends to be a really good option from the outside. We often get asked right at this point, Peter, right? Where does the water management layer go? Where does the drainage layer go? And Dorkin has provided some really nice details. I'm with Dorkin. They would show, most of their details would show the drainage layer to the inside of the foam. That is concrete, drainage layer, foam on the outside of that. And you're going to, well, I've got a little 3/8 gap. I have to step that. Well, they have details to figure out how to do that. In fact, in this case, you extend the drainage layer all the way above grade and use that so that you've taken into account this 3/8 inch gap that otherwise might interrupt the foam. This fits really nicely with net zero perspective of houses. Typically, people are using insulated sheeting on the outside of houses, and now it lines up really nicely. So that would be a preferred detail, in my opinion. I really like this particular detail, and obviously Dorkin can help you with these details and find what you need. And so you'll notice they make note of, so there's the bottom left there, the R15 slip sheet required by building code to stop that ad freezing, and then in this case showing the Delta MS in behind the foam. We really like that perspective of where that goes. Now I'm going to say, my opinion, R15 isn't enough in Minnesota if you're trying to get to net zero. Not if, when you try to get to net zero, we need a little more than that. Here's an interior insulation option. It doesn't have to be foam, but we prefer foam on the inside. Well, we prefer foam below grade. Below grade foams do a better job of managing or at least resisting moisture. Fibers have that complication of absorbing and holding on to moisture, and more importantly, creating points where it might have condensation within the insulation. So we like foam products. These products also manage vapor diffusion really well. We have vapor diffusion in the summertime, in cold climates, going from inside to outside, these products minimize that vapor diffusion, manage it really, really well. Of course, depending on where you're from in Canada, this is a challenge because our code does not allow us to have leave this foam unexposed. So you have to come up with a methodology. That's why I would say go ahead and finish your basement, take away that risk, finish that basement with, well, whatever material you want to use, but a drywall fire rated finish is what you'd like to get to. So I see it as a kind of a moot point because I have to cover the foam. Well, offer it as a finished basement. You'll find it's a pretty nice way to go. You want to create a thermal break, and notice how they've done it here. They've actually done the foam on the wall before they poured the slab. Now, some would say that's a little out of sequence. Don't know if I can get my guys to do that. But even if you just put a little bib of insulation, foam insulation, when you were doing the under slab, just ran a little 6-inch piece up the side so that you could pour that floor and get that thermal break in right at the beginning would be pretty useful. This, from an inside perspective, we really like this animation, or like this methodology. We like the animation, of course, because we drew it, but this idea of foam on the inside is really nice in a retrofit situation, very safe way to insulate. Now, you still want to make sure you got good water management. I'm showing spray foam here in the cavity. It doesn't have to be spray foam, but kind of a nice way to go. And then just this XPS, and we are suggesting XPS foam in this location. EPS is maybe slightly too permeable. The polyiso foams are too impermeable, so we like XPS with its semi-permeable. And now we're putting a stud wall in front. And you would say, well, couldn't I just do it all in foam? And the answer is, of course, do it all in foam, that's fine. But from a cost effectiveness standpoint, if you're trying to combine fibers, because fibers tend to be more cost effective than foams, this is a really nice way to do it. And now you have yourself this really nice, warm, dry basement wall. Again, still imagining I have my drainage layer on the outside. There's really no substitute for that. But drywall, no, for Canadians on this call, no vapor barrier. Use the foam. You show the foam as being your vapor resistant, vapor retarder in that wall assembly. And it works really, really well. This is studied at University of Minnesota, University of Waterloo, and shown to be a very good option in retrofit and even in new. I would like to mention, though, this idea of a hybrid option. Remember I said Minnesota probably doesn't have enough insulation at R15 once you get to net zero. I kind of like this one, that you do the below grade portion on the outside, and then you insulate on the inside. And by all means, insulate full height. What's really nice here is that foam on the outside created a really nice, much warmer concrete. And now you can go ahead and put in a modest amount of insulation. It doesn't have to be a lot. R12 on the inside, very cost effectively. You're going to put up a stud wall anyway, so just go ahead and fill that cavity. It doesn't have to be a lot. Minnesota would say you're allowed R11 or R12 in that cavity, and that ends up being a pretty good number. This means you don't have to finish the above grade. You do want the overlap to be at least 2 feet between the inside and outside, but I would say just go ahead, you're building the stud wall anyway, just go ahead and insulate all the way to the floor. This manages diffusion and drying really well. It still allows some drying to the inside. So that ends up being a really nice basement wall system. I do want to mention this, though. I'm just showing an old rubble foundation, but notice that on the left-hand side, that's the thermal gradients without insulation. And notice what happens to the thermal gradient when you add insulation. Perhaps not oddly, but interesting, is that when you insulate the wall full height, the frost actually goes deeper, which isn't that big a deal, but you will find the floor gets colder. So if you don't insulate your slab, there's a synergy here to insulating both the wall and under the slab. And if you don't insulate under the slab, oddly, in cold climates, you're going to get clients who go, geez, you say you have a great basement, and you do, well insulated, but if you don't insulate on the slab, they're going to notice the slab's actually cooler than what it would be if there was no wall insulation. So really the point we're going to make is you want to do both. From a synergistic perspective, you want to do both. This was the accumulation or the conclusions from that study that I mentioned. And I'll just read these two. I know it's not that long, but from a builder perspective, it may be, in fact, they went further than that, but it may be more profitable to construct what they deemed a Class A basement, which was full drainage layer and full height insulation. Just so we understand this, more profitable to put in drainage and full height insulation, because it simultaneously reduces the cost of callbacks and improves your profit margin because of that basement upgrade than any other basement system. So people say, well, it's going to be more expensive. It actually ends up being more profitable. Yes, more expensive, if you will, but more profitable for you. Homeowners are going to finish that basement anyway. All we have to do is help them bring those dollars forward. Somewhere in the next 2 to 5 years, the evidence shows people finish their basements in some manner or form or shape or other. And so you might as well just help them pull those dollars forward, find a way to do it that's cost effective for them. And interesting enough, for all types and sizes of basements, this study found that interior insulation, internally insulation was in fact more cost effective. But most importantly, to a level of R20. That is, R20 had a better life cycle cost than R12. So don't stop at R12 or 11, whatever your code says. It's actually more cost effective life cycle cost. Yes, more expensive to apply, but lower life cycle cost to go all the way to R20. So hopefully you find that interesting. Work has been done by folks. Just a little example of that. I'll go to this one first. There's code minimum levels of insulation. And notice the basement on the right-hand side, second from the bottom, 23% of the heat loss of the house is associated with the basement. That's code levels of insulation in a market that requires full height R12 code. R24, the basement is now only 14% of the heat loss. In other words, for simply adding an extra R12 bat, if you will, to the inside of a basement wall, pull the studs off a little bit. You can see why this is so cost effective. The studs are already there. You already have folks there. Just go ahead and put in more insulation in that wall. I'm going to say do it with foam, an inch of foam or an inch and a half of foam on the inside, but very, very cost effective to get you where you want to go. And as I finish up, just a couple of more minutes, here's what you need to know. When you get to, and I use that term advisedly, when you get to net zero, you're all going to be doing it in the next 10 to 15 years. Some of you are already doing it. You're going to find in the climate zones that we're targeting today, 4 and above, R20 full height basement insulation is what you want. R7.5 under the slab. You're going to find most software isn't going to show that as being a big benefit. I'm going to have you do it for 2 other reasons. You're going to do R7.5 because less than 7.5 is really hard to work with. R5 breaks too easily. So R7.5 is 1.5 inches of XPS. Some would put down 1 inch of spray foam, which would be fine, another R7. But go to 7.5. And the second reason is it warms up the basement floor, which gives you more flooring choices. It gives you the ability to offer more choices without foot discomfort. And you still need a thermal break at the slab edge. So every net zero house we've worked on, a minimum of R20 on the walls and at least R7.5 on the slab. We said we were going to try to get you to our idea of perfect. This is where we feel is perfect. This is actually the experience of my partner, Andy Oding. This was the drawing that they did for their folks to show what their wall was going to look like. And in fact, on the wall, they did 1 inch to 1.5 inches XPS foam on the wall, and then R20 bats within the cavity, so with the studs pulled off a little bit, and 2 inch under the slab. You'll notice they didn't affect that thermal break. Well, actually they did, but just R5 thermal break at the slab edge, but not on top of the footing. So they were very successful with this. I'll show you why in just a second. This was the consumer piece that they, when they did this basement, they called it form to function basement, and they got tremendous feedback. One, they had fewer callbacks. So here's what they did. They said, if you're going to finish your basement, this is the only way we're going to do it. And if we don't finish it for you, we're going to tell you you can't finish your basement for at least 2 years. That's hard to put into a contract, but they told people if you finish it within 2 years, the basement isn't dry. So they really encouraged people to let them finish the basement for them. And they found they had fewer callbacks. They made greater margin on the basement than on many other aspects of the house. They met their energy program requirements, at that time Energy Star, now Net Zero. And most importantly, they had great consumer acceptance and uptake. They actually went from not wanting to do basements to finding to be very successful to do basements, and encouraging their salespeople encouraged it. So I thought it was a really cool idea to think about. I need to mention one other thing before I finish up, and that is plan for dehumidification. All basements in cold climates need dehumidification, spring, summer, and fall. In the spring, our soils are wet, our soils are damp. Our air is cool, our air is damp. And basements end up needing dehumidification. The products on the right are whole house dehumidifiers. The product on the left, and you could just go buy a portable dehumidifier and give it to your clients. Many builders I know do that. The one on the left is a kind of a cool product, an in-wall product if you're finishing the basement anyway. This is by Ultra Air out of Minnesota. A really nice, dead quiet product, built-in dehumidistat, drained, you pipe it to a drain, air intake at the bottom, air out at the top, and it'll manage that moisture level. And you need to set it to 50%. That's where you'd like to be, 50% plus or minus 5. So no matter what you do, you've done great drainage on the outside, you've done good insulation. I'm still saying to you, put into your scopes that you're going to put in a dehumidifier or require people to run a dehumidifier. And that about does our time. I would just say thank you very much, Peter, for the opportunity again. Hopefully that was useful to folks, a quick 45 minutes. Let's think about questions.
That was great, Gord. I truly appreciate all of that information. Some of the questions that have come up in the Q&A, several relate to the location of the perimeter drain on the exterior of the foundation. Where should it be? Should it be on the footing? Should it be beside the footing? If it's beside the footing, are we risking capillary wicking? What's the best way to manage the water once we've put our drainage sheet on, taken the water down? What's the best way to manage it now?
Right. So maybe I should go back to just to show the kind of Dorican preferred, if you will. Let me just get to that. Where were we? Sorry, there we are. Go here, and you're showing drainage beside the footing. And this, when you think about, I'm trying to protect the footing. Okay, so I want as much water away at the footing level. So the drain should go beside the footing, but notice the lengths that have gone to here. One, that capillary break on top of the footing, and then that cold joint sealant over top, and then the drainage product that extends out over the top of the footing. So that is the best, well, that's where you'd like to be. In fact, that's what codes would tell you to do, quite frankly. That's where it should be.
Yeah, code actually would have the drain board stop at the footing and not make the turn across the footing. But I think as you pointed out numerous times, code is a minimum standard.
Code's a minimum. Yeah, so we like that extension, just encouraging that water, any water on the top surface not to get to the footing. Remember, you're trying to protect the footing. So,
and the cold joint.
And that cold joint as well, yes.
So I'm sure in your business, Gord, you've dealt with crawl spaces numerous times, both conditioned and not conditioned. How would you recommend people think of crawl spaces?
Yeah, crawl spaces are really basements for short people. That's the way they should be looked at. Build them the same way that you build a basement, the same drainage. In northern climates, if you're going below grade, A, don't just do slab on grade, but B, if you're going below grade but you're stopping at 2 or 3 foot depth, then treat it like a short basement. Water management, insulate the side walls, insulate the slab if you'd like. We would say manage that water. You'll notice here the drainage membrane underneath the slab. We like to see a rigorous membrane certainly on top of the stone. So it could be 10 mil plastic, but I love your product here. It's a nice sheet good, easy to roll out, tape the seams, and it's rugged enough, rigorous enough that maybe I don't know, Peter, would you allow that to be left exposed in a crawl space?
So long as you're not getting UV exposure.
Yeah, exactly. I always say pour a rat slab, like a thin slab, so people then can use that space. But always treat it like a short basement. Now, if you're in a warmer climate, there is no frost line, and your crawl space is above grade, okay, that's a different story. Then it's a vented crawl space. The problem with below grade vented crawl spaces is they don't really do what you want them to do. You think that venting is giving you drying, and most of the time it's actually making the crawl space more damp. So we could do that in a whole nother session. The shortcut is this: treat it like a short basement. water managed on the outside, insulate the basement walls, a foam product, whether it has to be covered or not, the US doesn't have to be covered. You can find like a Thermax or something that doesn't need to be covered. In Canada, you would still have to find some fire protection for that foam. Never in a crawl space use fibers on the inside, in my opinion. They're just too susceptible to moisture. And lastly, dehumidifier. Same three things: good water management, insulate sidewalls, dehumidification.
That's some great points, Gord. Along the same way, when you're talking about types of insulation, a couple questions we have here deal with the idea of continuous insulation, the perfect wall. So what we're driving here is, what about air barriers and vapor barriers as two separate control layers on a basement?
Sure. First thing to understand is poured concrete is already an air barrier. Okay, so you don't need to dwell. That's why I kind of left air grayed out. Certainly the rim joist area, the header box joist, whatever you call it in your area, that's a spot of air leakage. And where the top plate connects to the foundation wall, that's a spot of air leakage. But frankly, concrete walls themselves are already airtight. The joint between the concrete wall and the slab isn't necessarily airtight. Okay, but I'm going to put a thermal break there, and then I can caulk that if I needed to. So the concrete itself is an air barrier. So definitely vapor barrier and air barriers are separated. What we'd really like to get to, and again, if there's Canadians on the call, they know we have to put a vapor barrier on the inside of that basement wall. We don't really want it there. We prefer it wasn't there, and their code changes allowing it to happen that you don't need it there. So the vapor barrier in that case, you would just hang. You don't need it to be airtight. You would just hang it up. And you would use, my opinion, you'd use a smart vapor barrier. That is a vapor barrier that's able to change its permeance based on the moisture content that allows some drying to the inside. Better yet, though, is foam. And this is why I'm really suggesting you finish the basement wall. Because if you don't finish it, especially in Canada, you put up your bats, you hang vapor barrier, and I know today, hot, humid day, there's all kinds of people with water dripping on the vapor barrier in their basement. And they're going to call you and say the basement's leaking. It's not leaking. That's vapor diffusion. You should finish that well. Put up the XPS foam. That'll stop that vapor drive through the wall. It'll also, if you do it in the right ratios, you can go to your building official and say, that XPS foam is my vapor barrier. It's warm enough, it's through the insulation or through the assembly at the right location, that it's acting as my vapor barrier. Better yet, insulate on the outside. If you insulate on the outside, now the concrete's warm, you don't need a vapor barrier on the inside. So insulating on the outside avoids the need for a vapor barrier on the inside.
Great answer, Gord. Great answer. Suppose we can't get to the outside in a retrofit, and suppose we still have a lot of moisture vapor coming in. How would you cope with the poured slab that way?
Yeah, it's a great question, and I love your product, that the Delta FL. Look at that on this drawing. Look at that membrane that's on the gravel. Think about that same product or same type of product on top of the slab. And then I did my own basement this way. 28 years ago, I didn't know enough. I didn't have anything under the slab. When I was refinishing the basement, I was having a little bit of moisture problem coming up through the flooring, I used that Delta Floor product, a dimpled plastic, rolled down in sheets, dead simple, took like an hour and a half to install. And now you can go ahead and put any flooring type you want on top. I hear a lot about, could I seal the floor, some sort of paint? The issue is those paints, those sealants ultimately blow off. There's some great ones out there, but they blow off, and now you're putting a flooring on top of it. Was the flooring compatible with that? We would always say that drainage layer, that 3H drainage layer, Delta Floor, similar product, and then you can go ahead and put your subfloor down. You've got yourself a great moisture barrier, capillary break, air space, vent space, really good choice.
Great, Gord. We're starting to get to the end here, but I think I've got time for at least one more question. We talked about a couple different foundation ways to build the poured concrete, ICF. What's come up a couple times in the Q&A here is, what about a wood foundation or a wood stud foundation? Do you have any special recommendations for that?
So are we talking the actual foundation wall preserved wood? Is that the intent?
That would be my interpretation of the question, yes.
Yeah. Oddly, we don't see them much of late. They were a huge flurry of activity I'm going to say, in my early part of my career, 80s and 90s, saw a lot of them. In, I would say, rural markets where it was hard to get, where you couldn't get concrete, ready mix. And there's absolutely, the same principles apply. What's the enemy of wood underground? Water. So I need really good drainage and really good water management on the outside, and then we're totally fine. I happen to know literally 2 miles, 3 kilometers from where I'm sitting right now, a builder who built a preserved wood foundation, the same builder who built my house, built a preserved wood foundation. It's going to say 89, 90. It's doing just fine. Now, we've got sandy soils here, so that drains pretty well. Not great from a capillary perspective, but he has good damp proofing at that time. Frankly, Peter, I don't even think he used a drainage layer at that time because that was way back when. But he certainly had good drainage with the sand and then good damp proofing, a coating on the outside, and it's worked just fine. There's no problem with it from my perspective.
Last question, and I think this is a common one that comes up. We were asked, what about drainage in steep slopes? But let's add into that question how to manage grading around the foundation in general.
Yeah, of course. Good drainage. So the nature of the beast is always this: drain the water away from the building 6 to 10 feet. You can't always get 6 to 10 feet, but if you're building on the side of a hill, what you need to do is cut back that hill enough that between you and the house and the hill, you still are able to take the water, 4 to 6 feet away, and put in a drainage swale at that point and drain at that location to take the surface drainage around the house, if you will. So you still would like the water to drain away. If you go, that's not possible. Okay, now that was one of those conditions I spoke of. Now you do need waterproofing. Now you do need more structural on that wall because it's going to be under greater pressure. And yes, you're going to need a waterproofing. Then you're going to need really good drainage. And then you're going to need really good below grade drainage of the detail you're showing here to make sure any water, the volume of water that's coming down the hillside, because now you're asking to manage the volume of water that's coming down the hillside. Yikes. So I'd have to have some really good soil geo work done to determine how much water I have to manage. And so that's where you convince yourself, or let's just cut the hill back a little bit or move the house forward a little bit and get that water. If I can be 4 to 6 feet away reliably, that is sloped away 5% grade, 6 inches over 10 feet, we can be really successful at that point.
Thank you so much, Gord. I really appreciate all of this excellent information you've given us, and the ability to have wonderful dry basements. We appreciate very much you taking the time to speak with us today, and we're all very well informed. So thank you so much. A reminder to all of our viewers that they will receive a link to this in a thank you email, so you can rewatch it at your leisure. So just a couple things just to help people sum up the day. Durkin does manufacture Delta MS, which is a below grade damp proofing and drainage layer. You can get great information right on our website, either by following deltams.com or by going to durkin.com. Delta MS is unique in that it is a center layer of recycled polyethylene with 2 layers, one on either side, of virgin polyethylene. That gives you the dual feature of being environmentally friendly with the recycled, but adds the durability that you just can't get from recycled by putting virgin on either side. Again, it meets all building code requirements, both in Canada and in the US. There's just a couple shots. You can see some great installations there. You can probably do a typical foundation like you see here with a skilled crew, probably within 2 hours. In the upper right, you can see the standard gun. That's just a standard Hilti, either GX3 or 1100. We also make out of high density polyethylene delta dry and lath, which is used above grade for drainage and ventilation behind reservoir claddings like manufactured stone or stucco. It goes on in a 2-in-1 process, meaning that you put on both your engineered rain screen and your lath in a single step. You don't need the heavy duty metal lath to cut. It all goes up in one step. And that adds a lot of drying reserve to your above grade wall. I don't want to leave this without reiterating that Gord is with Construction Instruction, and he is involved in this app. Any of the animations you saw on Gord's presentation today can be sourced free on the Construction Instruction app. We've been involved with this app from the outset, and I go on frequently and I learn something every time. You can find great technical papers and great advice, and it's right at your fingertips, free on Google Play or the App Store. Our next webinar, webinar number 8, will feature Graham Finch from RDH Building Science. If you're an AIA member, you will be able to get CEUs from Graham's presentation. He will be talking about lessons from North America's tightest building enclosures, as well as the building codes around air tightness for both residential and commercial high-rise structures. We look forward to seeing you again Friday, July 17th at 1 p.m. Eastern Daylight for the exciting Graham Finch. He's good every time. As always, you can see this video of this particular webinar, as well as a number of other things, such as A Cup of Joe featuring Dr. Joe Stiebrick on our Delta Academy site, along with other building science deconstructed educational videos. Since Gord was speaking net zero energy, you can see Dr. Joe talking about net zero energy houses and beyond there right now. Thank you very much for joining Building Science Deconstructed, brought to you by Durkin Systems. We look forward to seeing you again.
Thanks, Peter.
Thank you, Gord.